Hi everyone, I'm Yanbing, and thank you for joining me. So today I'm going to give a lightning talk about the Raster-to-Vector heat map, focusing on multi-scale visualization approach to mapping and interacting with big geospatial data. So when we talk about geospatial data, we generally deal with two main forms, vector and raster, and each of this has its own pros and cons. In web mapping today, most cartographers use vector data to display maps. On the right, you can see some beautiful example from our NACIS student dynamic map gallery. This winner highlights the aesthetic and both function appeal of the vector maps. However, when using vector data in web mapping comes with significant challenge, especially when working with large data sets. First, since vector data includes complex geometries and attributes, it can require substantial bandwidth to load and transfer efficiently over the web, which is like high data transfer cost. And second, rendering and interacting with vector data puts a heavy load on client-side processing, especially in browsers, which will slow down the performance. And as we zoom in and out, vectors need to be dynamically redrawn and reprocessed, which can lead to performance lags or delays. And this is especially dealing with large data sets. So, these drawbacks make it difficult and sometimes even impractical to use vector data for large geospatial data set mapping. So when we reconsider the strength of each data type, vectors offer scalability and interactivity, while raster provides faster rendering and simpler caching. So is there a way that we can combine the best of the both together? So this question forms the foundation of my research to develop a multi-scale visualization approach for rendering large geospatial data set on the web that seamlessly transition between raster and vector heat map based on the zoom level, aka raster to vector heat maps. So what is a heat map? It's a visualization techniques that use color intensity or hue variation to represent the density or magnitude of spatial phenomenon. Below is an example also from the NACIS map gallery, very beautiful. And I emphasize I put parentheses spatial here because heat maps didn't originally evolve from cartography. In fact, it is widely used in fields like biology and or statistics, where they often display data in grid formats. Like the example on the right, you can see a lot of different kind of variation of grid heat map. While the form varied, the underlying concept is the same, representing density or intensity through color. So heat map actually play a unique role in visualizing large geospatial data sets because they offer a different approach compared to our traditional methods. When visualizing massive amount of data points, we typically rely on two main strategies. The first is to aggregate and sample the data, like the figure showing in the 1C. And the second is to partition the space to disjoint area and aggregate the data within each region. This region can be defined either by spatial semantics, such as provincial boundaries, or by we artificially dividing the space into regular cells, figures in 1B. So while this method creates discrete values, heat maps stand out because they produce a continuous surface. Heat map, unlike the colorless map, where color often has the statistical meaning, the color variation in heat maps does not necessarily represent exact statistical value. So when I start reviewing the literature on heat maps, I noticed that there's so many some beautiful examples were hidden within overwhelming amounts of grid-based heat map, which is boring for me. Yeah, so there has been relatively little research focused on the geospatial heat map specifically. So this kind of got me curious about all the different kind of web-based tools out there for creating heat maps. So before jumping into building my own prototype, I want to get a good sense of what is already available and how these tools are used. So after dividing that, I end up classifying heat map into three main types, based on how they handle the data and interaction. And this is the start of my journey to finding all the web-based heat map creation tool. So the first type is vector heat maps, and these heat maps use the vector tileset or GeoJSON to represent data as dynamic vector points. So basically, they take data set like vector tileset or like points data, like such as GeoJSON or arrays, only like arrays of coordinates, and render them in real time. So a common tools for generating vector tileset is Tippecanoe. Some tools I found for working with vector heat map include MapboxGL, Leaflet Hits, Google Maps, Heatmap Layer, Heatmap JSON, etc. And the second type is raster heat maps. These are rendered as raster tiles, so basically like image like PNG or JPEG, and displayed as pre-rendered tiles. This makes them super efficient, especially at like lower zoom level. You can generate this tileset using like Datamaps or tile cache, and also Mapnik is a popular tool for handling them. I put together a table comparing like popular tools creating the heat maps along with the type of data set they use, their like performance, interactivity, and the other key factors. Like due to the time limit, I won't go into details here, but like the table give a quick overview of like each tool, and I'll show you like some example I found is really like fascinating. So in MapLibrary, this is an example from MapLibrary. So you'll notice like cluster gradually break down into individual dots as you zoom in. At a certain zoom level, like both cluster and dots are visible simultaneously. And this is like a example I really like from the visual heat map. So it's a like open source JavaScript module. It lets you control the size and opacity of the dots, but for like zooming, it requires using the translate X, Y, and zooming button on the top right instead of like you cannot actually doing the mouse panning. I also came across like these tools like called like heat mappers, although it cannot be used in my research, which I found like also like super fascinating. It's a web server that makes it like really easy for user to create a wide variety of heat maps for all kinds of data set applications. And one cool feature is that it supports the CurvePath heat maps, which just like one of the many times like it can handle. So right now it came to the raster-to-vector heat map, as I mentioned before, which raster heat map are used at lower zoom level for performance, and vector heat map are using at higher zoom level for better interactivity. So here's a demo from my advisor, Dr. Nelson's previous work. He used Java's bicycling trace data in Portland to create a raster-to-vector heat map. Like as you zoom in, you can see like how it seamlessly like transition from raster to vector, almost like without noticing. And also, like this POI project shows the pulse of the user behavior in the Great Los Angeles area, containing approximately 160,000 points. So the data are visible at like 3 different zoom levels. They used raster tileset for first 2 zoom level and vector tile for the third. So like in the POI example, they actually introduced a very interesting concept called the tipping point, like between rendering raster and vector tileset. You mentioned that given the noticeable difference in loading times, it's clear that you can't rendering like hundreds, thousands of points like singularly using vector format. So as you zoom in, vector tile loads more efficiently, but to maintain smooth performance and interactivity, the switch from raster to vector, this should be ideally happen between zoom level 12 and zoom level 13. So, but while like loading time is key to the contributor, the total number of points and map scale is also important. Yeah, and that is like a screenshot from their like results. It's like the work just started kicking off like at the early of July, so it's still on a very like early stage. So some future work I hope incorporate more is about first is assessing the tipping points, like analyzing how like data set and spatial density affect the optimal zoom level for like switching between raster vector layer. And second is about explore the visual consistency to investigate the use of visual variables to ensure like the seamless transition between different kind of two tileset formats, and also enhance the interaction. Because right now, like the raster layer set cannot like support like filtering or like other Interac primitives. Yeah, so it deserves like more like investigation. Yeah, and that's all for my presentation. Yeah, as I mentioned, it's like still on an early stage, so any kinds of feedback or comments would be like really appreciated. Yeah, thank you so much.
And we do have some time for questions if anyone has a question. Yeah.
So has your research only focused on the visual benefits of like the interactivity? Or do you also look into data management, like managing a raster data set and a vector data set that's equal, and perhaps the complication that might exist with maintaining data sets that change?
So your question was like, is that for the like interactivity? Does I also like investigate on the like the database management, right? That was a really good question. I actually like I haven't thought about that before, but I think it's also like a like field that like deserve more exploration. Yeah, because like when dealing, because sure, like when dealing with the data set, like for right now, like my test like data set was only for it's less than like 100,000. Yeah, so it's deserved to explore like in like different kind of like different sides of data sets, like how it's better to like for data maintain. Yeah. Thank you.
So question, so when you evaluate different alternatives, and I think you shared something about like the performance of the map, or like how long it takes, like what do you use to measure, like for example, like the size of the tiles or the loading time? Like is there some standardized way to measure how high quality or how smooth the map is?
So your question is like, is there any quantitative measurement like for the like web map rendering?
Yeah.
Right.
Or like what measures do you try to use?
So right now, like for the tipping point, as I mentioned, that was like the time, the full time when like loading the entire the data set. Yeah. We're also like considered to incorporate like other measurements, like the consistency, like between the switching between the raster and vector layer. Yeah, because as you can tell, for example, so for this example is, do I need to? It's kind of like very, like intuitive. You can feel that there's like a lag between when you're loading different like layer, right? You will get like, you will like notice, so okay, I'm like zooming in and the tile set is loading. Yeah, and compared to the first example, it's like you won't like notice, oh, actually there's a transition. Yeah, so this also like an important like metrics when like doing the measurement. Yeah.
Thanks.
Thank you.
Any other questions? All right, thank you so much.
Thank you so much.